Hello dear students, welcome to the lecture series of object-oriented programming. In this lecture, we are going to see the dynamic memory de-allocation in C++. We will see the use of new and delete operators with some examples. We will see why to use free store operators although malloc, salloc and free are available. We will see the dynamic memory allocation and destructors. We will see the smart pointers. At the end of this lecture, you will be able to understand dynamic memory de-allocation in C++ using delete operator. You will be able to use memory management operators and you will be able to introduce smart pointers. Let us see the dynamic memory deallocation. When an object is no longer needed, it is destroyed to release the memory space for the release. The delete operator is used for that. Let us see the syntax. Here we have a delete operator followed by the pointer variable. The pointer variable is the pointer that points to the data object created with the new operator. For example, let us consider p as a pointer variable which is created to point the data object with the new operator. So delete, which is a delete operator followed by that pointer operator followed by that pointer variable will delete the memory associated with that object. If you want to free the dynamically allocated array, then delete operator can use. Let us see the example syntax and example over here. Here we have the delete, which is a keyword, followed by the size of that respective array, followed by the pointer variable which is pointing to that array. Now here the size specifies the number of elements in the array to be freed. But the problem with this form is programmers should remember the size of that array. So every time whenever we delete the memory space which is dynamically allocated by the new operator, at that time every time we need to remember the size of that array. So in C++ you can use the syntax which is given here. Without specifying the size of that respective array, we can simply write delete followed by empty brackets followed by the pointer variable. For example, if I want to delete an array of size 10, then I can simply write delete followed by the square brackets followed by the pointer variable. Now here this is a this pointer variable is pointing to the array. Let us see the example here. Here we have a p value which is a pointer value and it is initialized as a null. Then using the new operator, the memory is allocated to that p value, and now the memory is initialized and the value as 29494.99 is stored to the allocated address. Now if you want to print this address, the value 29494.99 will be stored at that memory and it will be displayed. And using the delete operator, the p value will be deleted and the memory will be freed. Okay. Let us see the another example. Here I am using the constructor and destructor to initialize the object and to destroy that object. Now here I have created the array of object. Okay, now here I have used the new operator to create an array of object of a class random. Now when this main function will be executed, the the memory space which is associated with the three objects which are of type class will be assigned, and those objects will be pointed by this pointer variable a. So when I will execute this program and when I will run this program, at the time of object creation, this constructor will be called and that cout statement will be executed 3 times, as I am creating the 3 objects of type class random. And after that, when I delete that array of an object which belongs to class random, that that destructor will be called, okay, and it will automatically delete the array. Now let us see what will be the output. So here the constructor will be called for first object, then the constructor will be called for the second object, and the constructor will be called for the third object. uh, when we create an object using a new operator, okay, but when we want to delete the memory, when we want to freeze the memory which is associated with that objects of a type random, class random, then in that case the destructor will be called. So as the pointer variable is pointing to the three different objects, okay, three times the destructor will be called to delete those memory, to remove this array, to delete this array and to deallocate the dynamic memory. Okay, so three times the destructor will be called. So this is how we can use the new and delete operators in while creating the object array of object of a class of a respective class. Now let us see how the dynamic memory allocation and destructors are related with each other. Destructor is executed when an object of a class is destroyed, as we have already learned. The class destructor is automatically called to do the necessary cleanup before the object is removed from the memory in the following conditions. So the destructor will be called when a local object goes out of the scope or when a dynamically allocated object is explicitly deleted using the delete keyword. So if you observe in the previous example, when we use this delete keyword over here to delete that respective array, at that time the destructor will be called. If your class object is holding any resources such as dynamic memory, a file, database, or if you need to do any kind of maintenance before the object is destroyed completely, the destructor is called. So it is typically the last thing to happen before the object is destroyed. So here the object, that is array of object, is going to be destroyed using the delete keyword. So before that the destructor will be called to indicate that yes, now the object can be deleted. Now let us see why do we require the pre-store operators. As we have the malloc, free as well as salloc functions to allocate the memory dynamically, why do we need this new and delete operators? Where we need to work with the classes, where we use constructors to assign the values to the data members, new is used and it allocates the space to hold the object. The new calls the default constructor. The new automatically computes the size of a data object. We need not to use the operator size of. So when we use the different function to allocate the memory as a malloc and salloc, and when we use the function free to deallocate the memory, so of course while allocating the memory we need to use the operator as a size of to calculate the size of that respective object. But when you use the new operator, this operator, no need to use this operator, and the size of data object will be automatically calculated. As well, the new automatically returns the correct pointer type so that there is no need to use a typecast. But when we use the malloc, free and size functions, at that time we have to use the typecast operation. We have to perform the typecasting to convert from one type to another type, that is a pointer type. Okay, but when you use the new operator, it automatically returns the correct pointer type. Almost it is possible to initialize the object while creating the memory space, and the new and delete operators can be overloaded also. So we use the free operators, that is free store operators, new and delete operators. Let us see the smart pointers. The smart pointer is used to manage the lifetimes of the dynamically allocated objects. They ensure the proper destruction of the dynamically allocated objects. Smart pointers are defined in the memory header file. Smart pointers are built-in pointers. So see, these pointers are same as your pointer variables, but these smart pointers are defined in the memory header file, as well as they ensure the proper destruction of the dynamically allocated objects. The smart pointers are built-in pointers, and we don't have to worry about deleting them. They are deleted automatically when we create the memory using the new operator. That is, of course, we have to use the pointer variables, and when we are after performing some operations, when we want to free that memory, okay, at that time we have to delete that pointer variable to so that the memory should be freed and can be should be or it shall be used by other variables. Okay, but when we use a smart pointer, we don't have to worry about deleting this those smart pointers. They will be automatically deleted when our work is done, or when our program will be uh, completed. So here is a simple example of smart pointers. Here we have SPTR. PTR is our smart pointer over here, and if we write new SPTR, then the smart pointer will be created, which will point to some action, and it will delete that respective pointer when the program is over. So this is how we can mm, deallocate the dynamic memory, and we can understand the deallocation as well as allocation of the memory and destructors. Okay, so we'll meet in the next lecture. Thank you. Have